In these problems, we're being asked to find the perimeters, that is, the distance around the outside of something, of composite shapes. And composite just means made up of several parts. So like down here, you have, I don't know, three rectangles all smushed together here. And we want to find the distance around the outside. So really, we just have to find the measurements of all of these segments and add them together. At first, this might look like it's not really possible. We know the bottom is 30 here and the right is 20, but other than that, other than this little bit that's 5, there aren't any other numbers here. This is possible to figure out. You just have to infer some of the numbers, do some deduction, and be a little clever about it. Well, let's write down what we have so far. The bottom, I'm just going to keep track of it over here. B is for bottom, is 30. And then the right side is 20. So those are the first two pieces that we'll add together. One thing I notice here, let me grab a different color, is that along the top, I have this segment, and this segment, and this segment. All of those put together, end to end, would add up to this segment. You can just see that if you match them all up on the same up and down height, they would be as long as this. So that is another 30. So that's for the top. So the top is 30. And now we need to figure out this side and this side. We know that one. This part is the tricky part, I think. The way to do this is to recognize that if you cut a line right here, straight across, that this little chunk would be 5. So this is 5, so this must be 5. And then the two pieces you have left over are this one and this one. And if you were to stack those one on top of the other, it would be the same height as this chunk. So this plus this is 20. And then we have another 5 and 5. So altogether, that would be 30 for those pieces. So that's plus another 30 for what's left over. And if we add all that up together, 30 plus 20 is 50, so that's 110, and we're in inches here. All right, took us a little while, but we got there. Let's look at another one. This type of problem is pretty typical for these perimeter of composite shapes. You've got a couple of rectangles put together and then this half of a circle. The way I like to approach these is to just start filling in the sides that aren't labeled as much as we can. On this one, we've got a blank side here, but it looks like it's the same measure as the diameter of this circle. So this should be 6. That's not too tough. And then let's see, this side isn't labeled, but this distance right here plus this distance right here is going to be equal to the 9 across the top. So since this is 6, this must be 3. All right, it looks like we've gotten all the straight pieces. So let's add those together. We've got 9 plus 6 plus 6 plus 4 plus 3 plus 4. And then we're going to add in this curved part. Now this is half of a circle, and when we're doing perimeter, we're doing the circumference of a circle. So we want half of the circumference of a circle. The circumference of a circle is 2 times pi times the radius. And actually, it's because the radius is half the diameter. Another way to write this is that the circumference is pi times the diameter. And that's the one I'm going to use because we have the diameter here, so that's pretty easy. So we want 1/2 of this, because it's half of a circle, pi times the diameter is 6. Okay. Now we just need to do a little simplifying. 1/2 times 6 is 3, so this part comes out to be 3 pi. And then when we add these together, 9 plus 6 is 15, 21, 25, 28. Looks like 32. May want to double check. But I'm getting 32 plus 3 pi. And oh, yeah, that's right here. Let's look at one more. This is a tricky type of problem because it has to do with triangles, and we're going to need to use our knowledge of the Pythagorean theorem to figure this one out. So we have these two sides with a single hash mark in them. That means they're the same length as each other. And then these two sides have 2 hash marks in them, which means they're the same length as each other, but not the same length as these two. And then we've got this side that has an 8 out here hanging out. So I guess if we're going to add all this together, we're going to have the 8 side. We're going to have these two sides. So I'm going to put 2 times double hash mark plus, don't think of that as an 11, and plus 2 times the single hash mark. So that's basically going to be the form we have. Oh, as I look at the answers here, already I notice we've got 2 of them with an 8 first, and then a bunch of these with the radical signs in them. Let's take this one piece at a time. I'm going to start with the single hash mark side. Um, it's so this side is 11, and this side is 11, and this is a right angle. So this is a 45, 45, 90 triangle. And a 45, 45, 90 triangle has sides that are in the ratio of 1 to 1 to the square root of 2. So if this side is 1, this side is the square root of 2. If this side is 11, this side is 11 times the square root of 2. So that's what that side is. And since this side is the same, that's 11 times the square root of 2. If you didn't remember this about 45, 45, 90 triangles, you could just use the Pythagorean theorem. Take 11 squared plus 11 squared and then take the square root of it. You should get 11 times the square root of 2. All right, let's look at, well, let's actually fill that in here. So we've got 8 plus 2 times our double hash marks plus, now we're going to have both of these. So 11 times the square root of 2 plus 11 times the square root of 2, you can add the 11s, you get 22 times the square root of 2. And that agrees with what's in our answer choice, so I think we're on the right track here. The last sides are tricky because these aren't triangles here, are they? So how can we figure this out? Well, I know this side is 7. If I move this line over to here, this line is still going to be 7 here that I drew in. What is this side going to be of the triangle? Because if we have that, we can use the Pythagorean theorem to figure this out. Well, if you look up here, this 8 should be divided equally between these two. So this distance right here should be 4. This whole side down here is 11. So what's left over should be 7. So what do you know? We've got another 45, 45, 90 triangle. These two sides are the same. This is the hypotenuse here. So this is going to be 7 times the square root of 2. Of course, you can use the Pythagorean theorem on that too. Multiply 7 squared, take 7 squared plus 7 squared, and then take the square root of that. You should get 7 times the square root of 2. So we've got 2 of these. This is also 7 times the square root of 2. We'll add those together, and we'll get 14 times the square root of 2 plus 22 times the square root of 2. And it looks like they didn't even bother to add those together. We've got them both right here. So that is a little bit of work with perimeters of composite shapes.